Avek, so what are you going to explain today?
A NAND gate.
NAND gate, okay. But what are those in your board?
These are extra cubes. This one is, I don't know what exactly is this one.
So what did you make that one? Okay. And what is that?
These are 240 cubes. Now I'm gonna erase these.
So what's that called? 240 cubes. What's that called?
If they're connected, then it's called a pentaract.
Oh, pentaract. Okay.
But since they're not connected, it's not called a pentaract.
Okay. So you're gonna explain us today the
NAND gate.
NAND gate. Okay. Let's see.
These are all the complex shapes. Now I'm gonna put this here and delete this wire. Now,
So what gate was that originally?
this gate was originally an OR gate.
Ah.
Now this is a path of more resistance. So this is the output, Q.
And so what did it become?
A NAND gate.
So can you explain how this thing works? So in here in the circuit diagram?
Now, if one of these, okay, so it takes AND, but then takes the not, then does this gate to AND. It just does AND then it does not.
Oh, okay. So now what happens if I give input to the A?
Input to A, it will still go through Q because B transistor is blocked. I mean off. B is off.
And then?
If we put input on B, A transistor is off, so it will go through this path again. Now, if you put both transistors on, then it will flow this way, and it will flow to ground without ever going to Q.
Why it doesn't go to Q?
Because there's a resistor here, and electricity takes a path of least resistance.
And which is the path of the least resistance?
The path of least resistance is, that's the path of least resistance.
Ah, okay. And what gate is this one?
This is NAND gate.
Okay.
Now let me show you this.
Oh, that's a symbol for the NAND gate?
Yeah. NAND.
Okay. So do you have a circuit to show us, demonstrate us?
Yeah. Currently the LED is already on.
Why it is on?
Because look at the truth table for NAND. It's this 001, 101, 011, 110.
Ah.
Now let's see it's working.
So what you're doing it? Can you tell me as well? What you're doing here?
I'm pressing buttons.
Okay.
Now this is 00, this is 01, this is 10, and this is 11. So it's taking the AND of these two buttons, and then it then applies a NOT operator.
Ah, okay. Just do one button at a time and then see. Okay. Still output, there is one. 1 0 is still 1. Cool. Nice. Thank you, Avek.
Now this is how we make an OR gate out of only NAND gates. Now let's see what is OR. OR equals OR is NAND of not of A and not B. Now not equals to NAND of A and A. Now let's draw it. So now A and B, and here's the Q. Now let's make the NOT gate. And then finally, let's put the NAND gate. Now
So it's a NOT gate or a NAND gate at the end? It looks like a NOT gate. Is that a NOT gate?
It's a NAND.
Okay, so this is like a triangle, right?
This.
Okay. Okay.
Now let's see if this works. 0 0 1 1. Now 1 NAND 1 equal 1 NAND 1 is 0. Now 0 1 1 0. 1 NAND 0 equals is 1. Now 1 0. Now 0 1. NAND 0 NAND 1 equals to, is still 1. 1 1. 0 0. 0 NAND 0 is still 1. So it's an OR gate.
Can you write the truth table for this one, this output?
I've already written it.
No, from this circuit diagram.
This. So now
can you explain me one more time how Q equals to 1? So how did you do? So I know you did it in your brain, but can you explain me how it becomes? So can you show me the output at each step?
the output
At each step, right? First NAND, and what's the output for the first NAND, and what's the output for the second input NAND, and then can you show me? So if you put something here, what will be the output here? What will be the output here? And what will be the output here? Say
now the output here is
with the input. So write down the input and then show me.
I'll write random inputs.
Okay. Okay.
Now not 1 equals 0. Not 0 equals 1. Now NAND of 1 and 0 is 1.
Okay.
Now this is how to make an OR gate only out of NAND gate.
Okay. Cool. Thank you.